Okay, so we have very thoroughly covered lists, how to create them, how to access individual items or slices from them, also how to modify individual items or slices from them. We introduced 11 named methods that you can use to interact with lists. And we also described the important idea of shallow copies of a list. So if a list contains something like a list as a component, and you make a copy of the original list, the copy of the list will contain a reference to the same sublist. It will not contain an independent deep copy of that sublist for itself. Next, we're going to take a look at tuples. A tuple is enclosed in parenthesis characters rather than in square brackets as a list is. You do access individual items as you do in a list from 0 to n-1, or in reverse order from -1 to -n. Rather than using parentheses to access items, you use square brackets just like you do for a list. So this may be slightly puzzling to begin with. Anyway, here I'm going to create a tuple containing 7, 2, 3, 0. This tuple has 4 items in it. A tuple is a sequence, it is a collection. I can ask what the length of T is. And I can access individual items within T by using subscripts between 0 and 3, or subscripts between -1 and -4. Okay, so T sub -1 is the last item, T sub -4 is the first item within this tuple. And as we've seen, just like in a list, if you try to access outside the bounds of a tuple, T sub 5 is an error. Okay? One important difference between a tuple and a list is that you cannot modify items in a tuple. That is, a tuple is immutable, whereas a list is mutable. I still have this list V hanging around, and I can say things like V sub 5 gets 3.333, and that modifies an item from V. But if I try to say T sub 2 gets a 5, I get told a tuple does not support item assignment. Just as with a list, the items in a tuple can be of different data types. So it's fine for me to have a tuple containing an int and a stir and a bool and a float and none. That's just fine. Concatenation and repetition with tuples use the plus symbol and the asterisk symbol, just as for concatenation and repetition in strings and lists. So here's T. If I say T plus some other tuple, 1, 2, 3, I get a new tuple, which is the concatenation of the tuple in T appended with 1, 2, 3. Or if I say T times 2, I get T repeated twice. And as we talked about with lists, and in fact in this case it's not really a special case because tuples use parentheses, I can go ahead and define a tuple across multiple lines because a tuple is already contained within parentheses, and parentheses allow me to continue my line. Alright, so now I have a tuple T2 containing these 12 items. Now creating a one-item list is pretty straightforward. I can just say something like V, let me continue to have just plain V hanging around here. So let me create V1 as a list containing one item, 1. But creating a tuple with one item is a little more complicated. If I say T gets 12 in parentheses, Actually, 12 in parentheses is just an integer, just like 3 plus 4 in parentheses is just an integer. So in order to force the parentheses to be treated as the tuple creating parentheses, we have to use this sort of funky notation of putting a comma after the one value that we want to have contained within our tuple. All right, so here, rather than being the value 12, because I've said t gets parentheses 12 comma, t is now a tuple containing the single value 12, the single item 12. An empty tuple is pretty easy. I can just use the parentheses for this. So t2 gets open close parentheses, does create an empty tuple. I can use the type function, by the way, to see that t is a tuple and t2 is a tuple. It turns out that if you use the commas between values, you don't even need to use the parentheses. Tuple packing basically allows you to leave out the parentheses. So if I say t gets 5 comma high, well, I made a typo, but that's okay. I hit enter by accident. So now I have a tuple with just 2 items in it. I can redefine t to refer to a different tuple by 5 comma high comma true comma 3.1415 comma none. That also defines a tuple, in this case a tuple of 5 items. So you'll often see tuples defined this way, just leaving the parentheses out. In fact, you can also unpack a tuple. More generally, you can unpack a sequence by having a tuple on the right side, or a sequence on the right side of the assignment operator, and an appropriate number of variable names on the left side. So t is 5 items long. So if I say A, B, C, D, E, separated with commas, gets t, the values within the tuple t will be unpacked, and each value, each item, will be stored sequentially, one by one, in these variables on the left. So A has a value of 5, B refers to high, C is true, D is 3.1415, and E finally is none. So of course I have to say print E in order to be able to see that. You can actually combine together tuple packing and sequence unpacking to accomplish what's called a multiple assignment. And this is very common in Python code. If I say A, comma B, comma C gets high 12, 2.7, the effect is that the 3 values on the right side of the assignment become the values referred to by the variables on the left side. So A is referring to high, B refers to 12, C refers to 2.7. Why in the world do we have tuples at all? Python is a relatively loose language in that it doesn't enforce very many rules. It's very rigid about indentation, but many other rules it's pretty relaxed about. Purely by convention, that is, this is a habit followed by skilled and experienced Python programmers, lists are usually assumed to contain values of the same type. Tuples are often assumed to contain values of different types. Of course, as we've seen, this rule is not enforced by Python itself. You can have a list of values of different types. You can have a tuple of items of the same type. But this is sort of by convention, that a list is thought of as being a collection of values that have the same type. A tuple is thought of as being a collection of values that have different types. A Python function, as we've talked about, returns one value, always exactly one value. If it does not have an explicit return statement, then a function returns the single value none. So, what do you do if you want a Python function to return multiple values? Well, a simple way of setting that up is to create a tuple of all of the different values that you want the function to return, and then you can return that tuple. Since a tuple is immutable, this is slightly safe for the calling code because the calling code is unlikely to accidentally change one of these return values that comes back with this returned tuple. So those are two reasons for having tuples. One is that we just want to have a conceptual separation between a collection that has all the same types and a collection that has different types. And we want to be able to return multiple values from a function, which we can do by cheating and putting those values in a tuple. A third reason for tuples, as we will talk about next week, are that sets and dictionaries store key values that are required to be immutable. And a tuple, therefore, can be a key for a set or a key for a dictionary, but a list, because it's mutable, cannot be. Okay, a tuple is iterable. I have this tuple containing these 5 items here. I won't retype this example on slide 54. I can say for I in t, do something with that value. I'm just going to print it out. All right, so this prints out 5 and then high and then true and so on. Because a tuple is iterable, if I have some list, I can insert the contents of the tuple somewhere in that list by using the list slice notation on the left side of an assignment. So here I'm saying v1:1 gets the contents of t. Okay, well, we already talked about the idea that 1:1 is a slice it's an empty slice that's basically like just ahead of item sub 1. And what I'm going to do here is to use my tuple t as the iterable that I'm going to insert into v ahead of the little h in this case. All right, so I've now extended v by inserting the 5 items read out of that tuple, that iterable t. Okay, a list is mutable. Both tuple and string are immutable, as we've said. If I have a list, I am allowed to directly modify the list. Let's be really careful about this. So here is my list, which has a certain ID number, and if I now say v plus gets some other list, well, let's use 3, 4, that's actually going to modify the list v. All right, v still has the same ID number, and it now has these additional couple of values, 2 and 4, appended on the end. If a tuple is immutable, what if we try to do the same kind of thing with a tuple? If we try to say t plus gets 3, 4, if a tuple is immutable, should this fail? Okay, that's strange. I didn't get any error message. Looks like the tuple t changed. Well, actually, no. Because what's going on here is that for a tuple, the plus gets operation is actually implemented by saying, let's start over again with our t containing 1, 2 initially. So t is a tuple containing the items 1 and 2. And if I ask for the ID of t, I get some number. Now, if I say t plus gets 3, 4, and then I look at the ID of t, what I'm going to see is that, no, I didn't actually change the original tuple. What I actually did was to create a new tuple. Because whereas for a list, the plus gets directly modifies the list on the left side of the assignment, for a tuple, the plus gets is literally implemented as t gets t plus, let me do 5, 6. And here now we can see what's actually going on, because T here is going to give me a copy of the tuple that's currently referred to by T. I'm then going to append this tuple 5, 6 to that copy, and then the reference T is going to be changed to refer to that new tuple. Okay, so in each case, although it may have appeared at first glance that we were modifying the contents of the tuple, what in fact we were doing in the case of a tuple is creating a new one by using the original one and appending a copy of the original one with another tuple. Strings are also immutable. If I say s gets hello, I can't say s sub 0 gets h. All right, I get yelled at because assignment is not supported for a string. But I can, for the same tricky reasons that I could for the tuple, I can say s plus gets, comma, world, because this is not actually modifying the string hello. This is just modifying the reference s to refer to a new string, which is hello with comma space world appended. Okay, so what does that mean? Well, it means two things. Tuples and strings are not mutable, but it's easy to just create new tuples or new strings by appending using the original tuple or string. Okay, so let's suppose that we have this tuple here. Bald eagle I can't type. Soars. Well, I shouldn't create for myself such complicated examples. That would be easier. All right. Now, let's suppose that I want to change T to refer to a modified version of this tuple. Well, one way I can do that is to just take slices of the original tuple. All right, I can use slices with tuples the same way I can use slices with lists, or with strings for that matter. And so I'm going to say, give me everything up to but not including the sub 1 item, that is, everything up to but not including bald. Then let's have golden. And here, because this is needs to be a tuple in order for concatenation to work, I'd better remember my comma after golden. And then following that, we're going to append everything from item sub 2 to the end of the tuple. Colon, not semicolon. There we go. So now I have modified the reference T to refer to a new tuple that is based on parts of the original tuple T. So that's basically all there is to know about tuples. Since tuples are immutable, there's much less that you can do with them than you can do with lists. And yet tuples are nevertheless very widely used in Python programs. Finally, the last thing we're going to do in this week's lecture is doing input and output with files. So here on slide 59, I have a very simple Python program that opens a file somewhere on your disk, reads the lines from that file one line at a time, displays those lines, again one line at a time, and then closes the file when done. I've opened that program. It's called disp_file.py in my idle editor over here, and we'll take a look at how this thing works. Now, in order to access the contents of a file, you have to open the file. Python provides open as a built-in function, and open takes various arguments. The first argument is what's called the path name of the file that you want to read data from. If the file that you want to read data from is in the very same directory in which you are running your Python environment, then you can simply specify the name of the file that's in that same directory. Here, we're supposing that I have a file named infile.txt in my same directory that I'm currently running my Python environment in. I don't actually have that file in my directory, so in that case, what I need to do is to specify something called the path, that is the sequence of directories leading up to that file that I want to open. And the path here can be typed using slashes between the directory levels, either on Windows or on a Mac or on Linux. So you can use the / as a directory separator in any operating system. Now, the backslashes you can use in Windows, for example, and I presume these will also work in Mac or Linux. The problem with using backslashes is you have to remember to double them, because the backslash, recall, is used to introduce or to indicate a special character like a new line character or a horizontal tab character or something like that. So it's much more convenient to just go ahead and use / rather than having to remember to type pairs of backslashes between the directories in a path name. Now, I happen to have a directory on my system named, let's see, users J Ostland pp2019 _ examples. Okay, so that is a directory that I do have on my Windows machine, and that does contain example programs that I've saved, and also contains some input files that I can use. In fact, if you look up here, you may not be able to see this very well, but you'll see in the top line of my editor, this particular program file that I'm editing is /users /jostland /pp2019 _ examples dispfile.py. So I want to open a file that happens to be in the same directory that my program lives in. Now, saying that the program lives in this directory does not mean that this is the current directory of my overall Python environment. It's just a directory where I am choosing to store program files and data files for the examples that I'm looking at. I don't happen to have a file whose name is infile.txt, but I do have a file whose name is expenses.txt. And let's confirm that. Here's my directory. I want to go to, I want to go to my C drive. And within the C drive, I will go to users, jostland, and here is my pp2019 examples directory. And in here, I do have a text file whose name is expenses.txt. So that file does exist, and it does exist in the directory where I claimed it should. Okay, so we're going to open that file. Now, we want this file to be an input file rather than an output file. So the next argument that we specify to the open function tells the type of access that we want and whether this is a binary file or a text file. So R here means that I want to read from this file. If I used a W, that would mean that I want to write to the file, and in that case, in fact, the contents of the file would be overwritten. So I need to be careful to use R here rather than W because I want to read this file. This is also a text file, as opposed to a binary data file, so that's why I have the little t. Okay, so RT is a code that will let you open an input file for reading text. The third argument that I give here specifies the character set in which this text file is encoded. My file is actually an ASCII file, but ASCII, as I've said, is a subset of 1-byte UTF-8 Unicode character set. So I'm going to say encoding is, quote, UTF-8, quote. So that's how I specify that this is a UTF-8 file, which includes ASCII as a subset. All right, well, presumably that open function will work. We'll find out in just a moment here. And if the open function works, I will get back from open something called a file handle, or an input file object. So I'm calling that thing fin file input. All I want to do with this file that I've opened is to step through the lines in the file and display them. It turns out that an input file object opened this way is an iterable, which means that I can process the input from that file using a for loop. And in fact, each item that I read from this input file is a line of text. The next line of text up to including the new line character that concludes the line of text. So I'm saying for line in fin. Line is a variable name that I chose here. It's not a keyword. It's not required to use line here. I could have said for X in fin or for abracadabra in fin. But it's meaningful to me to think of each line of input as a line. So I'm saying for line in this iterable, the input file. And what I'm going to do with each of these lines is to simply print the line out to the screen. When I'm done reading my input file, I should be sure to close that input file so that later on in my program, if my program were longer, I could open the file again to read from it again. Once you have traversed your way through an input file using something like a for loop, you cannot then just continue reading from that same file all over again because you're at the end of the file. And if you continue trying to read from the file, each time you try to read, you'll get nothing, 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 nothing. So what we need to do, or what we can do, is to close the file so that later on, if I want to process the contents of that file again, I can open the file again, and that will start me over from the beginning of the file. All right, so that was a fairly long-winded description of a pretty simple program. Let me save the changes that I've made, namely typing in the directory where my input file is stored. So let me save that, and now we will run the program. And okay, we get output. The output, this file contains a sequence of expense records for expenses that occurred in February and March during 2017, during the year 2017. And the first line is a line describing what the fields are in each of these lines. Then we have data lines for each expense. And for some reason, you'll notice that these things are being double-spaced in the output, whereas they are not double-spaced in the input file. Let's confirm that. I'm going to pull up this is an application called Cygwin, or this, I should say, is a terminal in a package called Cygwin. And let me go to users, J. Ostland, PP 2019 examples. All right, so this is a Linux-like terminal environment, and ls lists the files that I have, and I can look at the expenses file by using a pagination command called more. All right, so here is what the actual contents of the expenses file looks like. You can see that in the actual file, these are single-spaced, and yet for some reason in the output, they're appearing as double-spaced. The reason that they're appearing as double-spaced is because the new line character is included in each line read from the input, and when I print a line, the print function automatically adds a new line character to the output. Consequently, each line comes out exactly as it was read in, that is, the line of text with a new line, and then the print function is adding another new line. So the upshot is it appears that all of this information is double-spaced. I want to avoid that double spacing. In particular, to make these lines easy to process, what I want to do is to eliminate the new line character from the end of each line that I read in. I'm going to do that by adding one simple line of code here. For each line of input that I read from my input file, I'm going to strip off the new line character by taking a slice of the input line that includes all of the characters from character sub 0 up to but not including the very last character on the line. Now, because of the way the for loop works and because of the way reading lines from the input file works, line is guaranteed to end with a new line character from each line in the text file. And so it's easy for me to strip off that new line character by saying, just give me the slice of the line that includes everything except for that last character. And then when I print that line out, I will get the contents of the line apart from the new line with a new line added. So the effect is to avoid double spacing the output. Let me switch back to my program file, and we're going to make that modification. Okay, this file is going to be disp file no nl, no new line. And the only thing I need to do here is to say line gets. Recall that a string is immutable. So I'm not actually modifying the input string here. What I'm doing is I'm taking a slice of the input string up to but not including the last character, and I'm changing the variable name line to refer to that slice rather than to the original input line. Okay, now when I save this, I'm changing the name, so let me do a save as disp file no nl, no new line. And now when I run this, I no longer have the output double spaced. All right, so when you are processing text, this is a very common trick to need to use here, is to strip off the new line character from the end of each line of input. Finally, you might wish to create an output file containing the result of some processing. Using the open command, we can create an output file. The only thing we need to change is make the R into a W. So the way that we are opening the file here is to write to the file some text. The first argument to the open function is the path name and the name of the output file that you want, then WT, and then here we're specifying an encoding of UTF-8, which in my case is going to include ASCII as a subset. Let's take a look at this program. So here is my create file program. Now, path is not correct. I need to, again, change that to what is correct for my system. So that's going to be users J. Ostlund pp 2019 underscore examples. And I will just call this thing outfile.txt. In order to write data into an output file, you have to use your output file handle, and you can invoke the write method, W-R-I-T-E. Whatever you have as string arguments to the write method will simply be written out to the output file. Now you need to be very careful then to close the output file when you are done producing that output into the file, because if your program ends without having done a close, you may discover that your output file is incomplete. Some of the output that you wrote to the file may be still hanging around in the memory of your Python program and just get flushed away and not written if you forget to do your close. All right, so let me run this program now. I'm going to save the changes that I made to the path, and I will say run module. Okay, now in my interactive shell window, I don't see anything because all of the output produced by this program was, at least in theory, written into this output file called outfile.txt. Let me switch back to my terminal, my Cygwin terminal, and let's see whether in fact that is true. Yes, here I have a file named outfile.txt, and if I look at that with my pagination program more, I see, this is an output file containing 4 lines. All right, if we look at the program, notice that what we have here is a string. By the way, this is just a long string. Notice that we have a single quote here at the end of this is an output file. And we don't have any other symbols like plus or times or comma or whatever. We simply have another quote mark on the next line down. If you type a string immediately followed by another string, that is an implicit concatenation of the 2 strings. Okay, so if I say this is a string, notice I'm doing this in parentheses so that I can type my input across multiple physical lines. And this is a continuation of the same string. All right, so I have now typed one long line split across 3 separate physical lines by using the implicit concatenation of strings. I'm going to have just one long string now from that input that I typed. So that's the same thing that's going on here in the write function that we're using to create output into fout. New line \n creates a new line character in the output file. So because I have 4 new line characters here, I do get a file containing 4 lines of text. And then I've successfully closed the file. All right, so that completes the lecture for week 2. We looked in detail at list objects. We talked about how to define them, how to index individual items within them, how to concatenate them together with plus, how to repeat them multiple times with star. We saw that a list is mutable. That is, that you can change the individual items within a list. We also saw that a list is an example of an iterable, and so you can loop through the items within a list using a for loop. In addition to being an iterable, a list is also what's called a sequence. Now, a sequence, that's sort of a subcategory of iterables. A sequence is something that you can step through using integer subscripts. We'll discover later, next week, that there are also iterable things that you cannot step through using integer subscripts. We saw that there are 11 named methods that you can use to interact with lists. We also talked about the important idea that a variable name in Python is actually a reference. It does not directly contain a value. What a variable does is to refer to an object in memory, and that object contains the value. If an object no longer has any references to it, then the space for that object can be reclaimed for later reuse. This is not so important for individual int or float or bool objects, for example, but it's extremely important for things like lists of 1,000,000 ints or strings that are a megabyte long. We saw that, and again, this is actually because a list is a sequence, that you can use slice notation to get copies of subparts of lists. You can also use a slice notation on the left side of an assignment to change a portion of a list to something else. Finally, we introduced the important concept of shallow copying of lists, so that when you make a copy of a list, what you really get is only a new list that contains the same references to objects that the original list contains. If some of the objects within that original list were themselves sublists, then your shallow copy is also going to contain a reference to that very same sublist, rather than a reference to a separate copy of that sublist. We introduced tuples, which are very similar to lists, except that they are immutable. You can do slicing, indexing, concatenating, and repeating on tuples in much the same way you can do with lists. We also introduced the idea of tuple packing that allows you to define a tuple without using parentheses around the values within the tuple, and sequence unpacking, which allows you to take a sequence of values, whether that's a tuple or a list or a stir or a range, and unpack the individual items in that sequence into a collection of variables, like saying A, B, C gets hey. All right, there is an example of sequence unpacking. A is H, B is E, C is Y, or refers to, I should say. Even though a tuple is immutable, we saw that you can, in some sense, change a tuple or a string by just creating a new tuple and reusing the existing tuple variable name or string variable name to refer to that new object. And then finally, we took a look at reading and writing text files. Okay, so that is the conclusion of week 2.